Introduction to Quadratic Functions. So we're starting Unit 8 right now, and up until this point we have been dealing with linear and exponential functions. And they say that these are relatively simple. And why are they relatively simple? Because either they're always increasing or always decreasing for all their domains or their x values. So what makes the quadratic a little bit more complicated is they're a polynomial function, and you're going to notice that they're increasing and decreasing. All right, so kind of cool. Quadratic function. So in general, okay, sort of the general form for your quadratic function is this y equals ax squared plus bx plus c. And it says where a cannot be 0, but b and c could be 0. So there is sort of a restriction on that. In order for it to remain a quadratic, a cannot be 0. It could be a positive number, a negative number, a fraction, a decimal. It can be anything you want other than 0. So what do we mean by this general form? So when you think about a linear function, okay, we know linear is y equals mx plus b. That's your basic linear function. And then y equals a times b to the x, that's your basic exponential function. So now we have the basic form for the quadratic. So let's take a look and sort of pick this apart a little bit. It says, why is it important for the leading coefficient to be non-zero? Okay, so the leader, the a, okay, why can't a be 0, in other words? So let's think about that. So if I made that leader 0, and I can make, I don't know, anything else for b and c, what happens if we start to simplify this? What is 0 times x squared? That ends up being 0, and now we have 2x plus 1. So what is 2x plus 1? Is that quadratic anymore? And hopefully you're saying, no, that's linear. Okay? So that's why it's important for that a value to be non-zero, meaning not to be 0. Okay? Because if it's 0, we end up with a linear. So it says in part B, circle the choices below that are quadratic functions. So meaning they fit our definition. So that one definitely is. Remember, and then if you look at it, it's got to have that form, that ax squared plus bx plus c. So this definitely has an x squared, and the a is 1, so that's okay. It doesn't have a b, which is fine because that b term or that x term is 0, and it has a constant of -3. So this one here, it starts off with an x cubed. All right, so when we look back at our definition, our highest exponent is x squared, so that definitely is not. Then when I look at this third one, y equals x squared plus the square root of x plus 7. Okay, that square root function we can't have in there. That makes it something totally different. And then this y equals 10 minus x squared, that is quadratic. It's just not written in standard form. But that's still okay. So if I have that in standard form, that's still acceptable. Okay? So part C says, given the quadratic function, and they list it out, write it in standard form and state the value of the leading coefficient. So two things there. So standard form and then who's the leader. So standard form, if you recall from last unit, we have to put the terms in order from highest exponent to lowest exponent. So my highest exponent term is that -3x squared. So my x squared is my highest exponent. So that's the leading term. Then it becomes 7x, and then we always put that constant on the end. It's kind of like the caboose of the train. So what's my leader? My leading coefficient. Now remember, a coefficient is just the number. It's not the variable. Okay, coefficient is the number, not the variable. So the leader is -3. Part D says it gives you a quadratic function. It says, then find, without using your calculator, the value of f of -2. So in other words, our x value is -2. They want us to find the y value that goes with it. So we've got some evaluating to do. And then it also says what point must lie on this quadratic's graph based on this calculation. So no calculator, so we got to do a little mental math here. So we're putting that -2, obviously, wherever we see our x value. And then, so -2 is our input. We're looking for the output that goes with an input of -2. So doing some evaluating. Now be real careful here. Notice I always put parentheses around whatever I'm substituting. In this case, it's a negative, so those parentheses are even more important. So I end up with 2 times 4 plus 6 plus 1. That's 8 plus 6 plus 1, okay, which is 15. So it says what point must lie on this graph of this. So we end up with, all right, so the point that's associated with that, the x was -2, and then the y was 15. So if I were to take this function, put it into my graphing calculator, I'm going to see that -2, 15 is in the table. All right, so if I look at that, okay, real quick, if I take and I put that in to a graphing page, so 2x squared minus 3x plus 1, enter. So that's what the graph looks like. And then if I hit Control T and I search and I go to -2, there it is, -2, 15 is on that graph. Okay. So going back to our notes here, and it says quadratics still behave in similar ways to other functions. Inputs go in, outputs come out, but they start to behave differently from linear and exponential functions because sometimes the outputs repeat, okay, which is kind of cool because the quadratic has some neat symmetries that happen. So what I'm going to have you guys do is you're going to do exercise 2 on your own and come into class with that done. When we flip over to the next page, you are also going to do exercise 3 on your own and come into class. Now, all of this stuff that is mentioned in exercise 3, okay, you know how to graph and come up with a table. You know how to find the range. You know how to find the domain and interval notation. So right here, part D, it says, state the coordinates of the parabola's turning point. Okay, this is also known as the vertex. So it's also known as the vertex, and it's also a minimum point. So turning point, vertex, minimum, they all mean the same thing. So let's see, I'm trying to think what else I wanted to give you guys. So when you've graphed it, okay, by the time you're down to D here, you've graphed this. So the turning point is this point right down here, right? Just so you know what that is. The axis of symmetry, okay? Axis, if you think about what the Earth rotates on, okay, that's an axis. And symmetry, you know that it means the same on one side as it is on the other. So the axis of symmetry, you're going to read from your graph in part A. And to give you just a quick little sketch of that, the axis of symmetry, okay, is that line that splits the parabola right down the middle. Okay, and they want you to draw the axis of symmetry on your graph, and then they also want you to write the equation down here. Okay. Then some hints on F. They're asking for the x-intercepts. The x-intercepts are where the graph crosses the x-axis. Okay? Just like you were so familiar with the y-intercept. The y-intercept is where the graph crosses the y-axis. So the x-intercepts are where the graph crosses the x-axis. Okay, so you're going to be able to see that. And then it also gives you some more terminology. It says these x-intercepts are also known as the function's zeros. And now it says, why does this make sense? Okay, so you're going to have to come up with a reason as to why zeros would make sense for the x-intercepts, and you'll see what we mean by that. Okay, all right, go ahead and flip over to lesson 2. Okay, more work with parabolas. And it says here, the graphs of quadratic functions are more complex than linear and exponential because they include a turning point. And we did touch on the turning point, okay, in lesson 1. And that turning point is either a maximum point or a minimum point. So if you think about maximum, it means the highest point, or is it a minimum, is it a lowest point on the graph? So today we're going to use the calculator to explore some of the parts to our quadratic function. Okay. So let's go ahead and let's see if, yeah, let's go ahead. Let's graph number 1. Okay, we'll do that one together. So go ahead in your calculator and let's graph. It's pretty simple. Negative x squared. Oops, let's get a clean slate here. So negative x squared. All right, it looks like that. And then you've got to fill in the table there. So when you go ahead and hit Control T, so what do we want to fill in? Because obviously there's an infinite amount of points here. So right in the center of your table, okay, you're going to want your turning point, because you're going to want to have 7 nice points that are going to give you a nice symmetric looking parabola. So obviously this already started it out for us. Okay, they listed the x's. So you go ahead, you don't have to fill in this middle column. By all means, go ahead and fill in your x's in your xy column. Okay, so that's the x combined with the y here, and then go ahead and then graph it. Okay, so kind of gave you some hints on that one. So then I want you to answer, what's the range of this graph? Okay, the range is the high point to the low point. So now there's a piece here that is really important / interesting to me, I think. And it says some parabolas are concave up or open upward. And that's what that means. That's concave up or open upward. And I say that parabola is a smile. So then just the opposite of that is some parabolas are concave down or open downward, and a sketch of that would be looking like that. So I say that's a frown. Now you're going to see if you can find some patterns that occur when you start to look at the equations and then some sketches of them. So I want you to do exercise 2 on your own, and then I want you to jot down in the margin down here, what patterns do you notice? Okay, patterns about the equations or patterns about the graphs, or both. Okay, go ahead and flip that. So make sure in exercise C, again, you're using your calculator and you're getting a sketch, okay, of these graphs. Okay, so you're going to be able to sketch those, and again, patterns. Okay, what is happening? Okay, after you do those 3. And then same thing, okay, what is happening after you do the next 3. So jot some thoughts down, okay? What do you see? And then you're going to go ahead and you're going to do exercise 4 on your own. All right, so lots of use of the calculator, and we're going to see some cool things with the quadratics.